Well, howdy, folks, and let us continue with our discussions of reactions. And we've kind of covered all the major reactions, and now we want to get into something that is regarding expressing those reactions. So let us look at this. Consider the reaction between aqueous silver nitrate with aqueous sodium chloride. Write the molecular equation, the complete ionic equation, and the net ionic equation for this reaction. What are the spectator ions? Okay, so I think we need some notes. So we're learning about reactions, and let's go back and kind of complete our concept map. We talked about chemical equations, right? And then we talked about the types of reactions. And we said we have synthesis and decomp and single replacement and double replacement. Oops, single replacement, double replacement, and I forgot what, combustion. And we have all these kinds of reactions, right? Now, I want to talk about expressing reactions, which is really another form of my chemical reactions over here. This is general, and this is more specific. Really, though, I guess, shouldn't I put this arrow off of chemical equations, right? No, I think we can go this way. We want to talk about expressing chemical reactions. Expressing reactions. Okay, and there are three types that we want to discuss. Number one is the molecular equation. Okay, now here's the funny thing. The molecular equation doesn't have just molecules. This is an old-fashioned word, old-fashioned phrase, old-fashioned name. It is not just molecules. It is, you have your molecules and you have your ionic molecules and ionic compounds. So it's kind of anachronistic, I guess, right? Or just wrong expression. Now, what is a molecular equation? And a molecular equation shows or illustrates all species, that means compounds and elements, all species as whole. Let's put it that way. As whole, that means not separated. And you'll understand what I mean by this when we get to the next. So it shows all species as whole, not separated. So let's do this. Here's my molecular. We want to show everything as being whole and not separated. So what does that mean? I have silver nitrate, and even though it's made up of two ions, we want to leave it whole and together. Plus sodium chloride. Once again, I have two ions, but in the molecular, we keep them whole and not separated. That forms what? Silver chloride, which is a solid, plus sodium nitrate, which is aqueous. Okay, that is your molecular. What we've been drawing all along so far have been molecular equations. Everything is written as a compound and not separated. Good. Next, complete ionic. Okay, so we have the molecular. We're going to come out of here and let's go to the complete ionic. Complete ionic. Now, how is that different, or what are we going to do here? The complete ionic shows certain species as individual ions, Okay, now what are these certain species? Well, any dissolved ionic compound. And if it's dissolved, that means what? Any ionic compound that is aqueous. Now, what is ionic? Remember, ionic is what? When you see your metal and your non-metal, if we see anything that is metal and non-metal that is dissolved, it is aqueous, then we're going to write these as ions. What else am I going to write as ions? Strong acids. Now, acids are molecular, but we're going to write them separated, and these are the strong acids we have to write separately. HCl, HBr, HI, H oops, HNO3, HClO4, and HClO3. That means when we write these in a compound, these will be written like this. Oh, excuse me, in a complete ionic reaction equation, hydrochloric acid would be written like this. Nitric acid would be written like the two ions which make it up, and chloric acid would be written like this. Okay, so that's what we mean when we say certain species are displayed as individual ions. So my acids, my strong acids, are broken down into their ions. Now, there's one other strong acid here that's a little weird, H2SO4, and we're not going to get into that. That's for AP Chem. But there we go. Those are our rules now for complete ionic. So what am I going to do? I'm going to take my molecular, and I'm going to identify all my ionic species that are aqueous. Yoink, yoink, I'm going to yoink. Notice, I'm not doing anything with silver chloride. Why not? Because it is solid. I don't mess with solids, liquids, or gases. Now, what do I want to do for my complete ionic? Complete ionic. I want to break these into ions. So that means I'm going to have Ag plus, and now what state is it? Well, it's aqueous, right? Plus, what's my next ion? It's not N, but it's NO3, right? My polyatomic. It's still aqueous, plus my sodium, plus aqueous, plus my chloride minus, which is aqueous, yields what? Do I break up my silver chloride? No, I don't break up my silver chloride. It says AgCl solid, plus Na plus aqueous, plus NO3 minus aqueous. There we go. That is my complete ionic. Not bad. And let us finish off then with my net ionic. Okay, so net ionic, we need a line. We come to the net ionic equation. And what is the net ionic equation? It really shows just species involved in reaction. Okay, so what does that mean? That means if I have a precipitate forming, only the two entities forming the precipitate are shown. Now that's a little complicated, but let me give you a little tip. Okay, so first thing we want to do is identify spectator ions. So what are my spectator ions? So spectator ions are ions which are exactly the same on both sides of the equation, on both sides of equation. So if I have an arrow and I have Na plus here, and I have on the reactant side Na plus here, well, those things are exactly the same, so that would be a spectator ion, meaning what? It's spectating, it's just watching, okay? So we want to identify the spectator ions, and here's the key. To convert from complete ionic to net ionic, what do? Eliminate, oh my, eliminate the spectator ions. So I'd hate to be a spectator ion, because then I would be eliminated. Too bad I can't spell either. Spectator. How about spectator? Tator. Taters. I like taters. To net ionic, okay, to convert from complete ionic to net ionic, eliminate the spectator ions. Cool. That's the only rule we have to deal with to get our net ionic correct. So let's go back to our reaction. Let's expand the page. Let's go with blue. No, not blue, green. Okay, now I want to look. Here's my yield arrow. Is there anything exactly the same on both sides? Well, here I have Ag plus. Over here I have Ag, but it's not Ag plus, so that's not exactly a light. So that is not a spectator. What about NO3? I have NO3 here. Do I have exactly NO3? Yeah, right here is exactly NO3. So the NO3 would be a spectator ion. I have one NaCl, excuse me, I have one Na plus here. Do we have one? Yeah, here. I have one Na plus here, so that's a spectator ion. So now what am I going to do for my net ionic? I'm going to write down my Ag plus aqueous. I'm going to eliminate my nitrate, eliminate my sodium, put Cl minus aqueous, and I'm going to form what? AgCl solid, eliminate, eliminate, and notice I formed a solid, and what two things were involved in it? Only these guys. This is my net ionic reaction. Piece of cake. All right, you guys try this one. Bring me back. Well, we start off with ammonium carbonate. So here's my molecular. I have ammonium carbonate. Ammonium's +2. Carbonate is ammonium is +1. Carbonate is -2. It is aqueous plus calcium chloride, aqueous. I'm going to form something. What am I going to form? Well, it's a double replacement reaction. It looks like I'm going to form ammonium chloride. I need 2 of those to balance the equation, plus calcium carbonate. And calcium carbonate, if we looked up in our solubilities, we'd find it is insoluble. So that is my complete ionic. All right, let's go with my, not complete ionic, that's my molecular. Here is my complete ionic. What do I want to do? I want to find all my aqueous stuff that are ionic. That's ionic. That's ionic. That's ionic. This is ionic, but it's solid, so I'm not going to mess with that. And I want to break them into ions. Okay, so what ions make up ammonium and carbonate? Well, ammonium and carbonate. But how many ammoniums do I have? I have 2 ammoniums. So that means this has to become a coefficient. So now I have 2 ammoniums that are reacting with 1 carbonate plus 1 calcium plus what? Now, what is my ion here? Is my ion Cl2? No. My ion is Cl's, and how many of them do I have? I have 2 Cl's around my calcium. So I have 2 chlorides, aqueous. Let's use more space here. And that's going to yield what? 2 ammoniums, aqueous, plus, well, I have 2 times Cl. That means I have 2 Cl minuses, aqueous, plus my solid, CaCO3 solid. Good? Now we want to do what? Let's see if we have any spectator ions. Well, I have 2 ammoniums here. I have 2 ammoniums there. Oops, that should be aqueous, sorry. I have 1 calcium here. Oops, nope, that's not, because it's in a compound here. It's not alone, so I can't get rid of that. Oh, here we go. I have 2 chlorides and 2 chlorides. So these are my spectator ions. Oops, not that. This is good. There we go. And so when I make my net ionic, what do I have? I have CO3, 2 minus, aqueous, plus what? Calcium, plus, which I shouldn't have put a line through, right? Leading to what? Calcium carbonate solid. Hey, that's a piece of cake. Sure is. Let's do a couple more, and then we will call it a day. All right, let's do this one together. This one's a bit different, but not much. What do we have? We have sodium hydroxide, So let's go with my molecular. I have sodium hydroxide, and it is aqueous, and that's ionic, right? Plus hydrochloric acid, HCl. It is aqueous. Whenever we see the word acid, we're assuming that it is a solution. And that's going to yield what? Well, we're going to have a double replacement reaction, and I'm going to form water, which is liquid, plus sodium chloride, which is aqueous, right? Good. Now, I want to break up my ionic aqueous. That's ionic, and that is ionic. What do I do about my hydrochloric acid? It's a nonmetal and nonmetal, but what do we know about hydrochloric acid? That's one of my strong acids, and that means I'm going to break it up as well. So let's go to the complete ionic, and I have Na plus aqueous plus OH minus aqueous plus H plus aqueous plus Cl minus aqueous. What do we do with liquid? We don't do anything with liquids. If they're liquids, they stay together. It's only aqueous ionic, or aqueous strong bases that we split up. Na plus aqueous and Cl minus aqueous, right? Good. Now, what are my spectator ions? I see a sodium here, a sodium cation here, a chloride here, a chloride here. So what is my net ionic? It is OH minus plus H plus yields what? HOH liquid. Hey, this stuff is easy. You got it. It is. All right, you guys do this one. Bring me back when you're ready. Okay, this one was a little tricky. You thought it was a piece of cake, but it really isn't. I have calcium carbonate, and it is solid, and it's reacting with what? Nitrous acid. What is nitrous acid? Well, that is HNO2, and that is aqueous. And what is it going to produce? Well, if you recall, this is a carbonate plus an acid, meaning we're going to form carbon dioxide gas plus water plus a salt. In this case, my salt would be calcium nitrite. And we don't really know anything about nitrite, so I'm going to assume that it is solid. Okay? Good. This is my molecular. So then, what is my complete ionic? Well, my complete ionic, do I break up my solids? No. So that stays CO3 solid. Do I break up, what kind of an acid is this? Well, we said our strong acids are HCl, HI, HBr, HNO3, HClO4, HClO3. Is HNO2 a strong acid? No, that's what we call a weak acid, meaning we don't break it up. So it stays the same. Yields what? This is a gas. Do we break up gases? No. This is a liquid. Do we break up liquids? No. This is a solid. Do we break up solids? No. Wait a minute. It looks to me like the molecular is exactly the same as the complete ionic. That is correct. And then what's my net ionic? Do I have any spectator ions? I don't have any spectator ions, so that means it is exactly the same. In this case, the molecular equation is exactly the same as the net ionic. Ooh, spooky. All right, here we go. Let's try this one. Solid sodium and water. Okay, solid sodium, I can do that. Plus water, HOH, liquid. And what am I going to form? Well, this is a what? Single replacement reaction. I'm going to form sodium hydroxide, which is a liquid. Liquid, no it's not. It's aqueous, plus what? Hydrogen gas. We need to balance that. So I need to have two of these, which means I need two of these, which means I need two of those. Good. So now, that's my molecular. Complete ionic? Well, let's find anything that's aqueous. Okay, here we go. Anything else aqueous? No, so we want to break that guy up. So it's going to be Na solid plus 2 HOH liquids yield what? 2 sodium positive aqueous plus 2, what's my other ion here? OH minus aqueous plus H2 gas. So that is my complete ionic. Do I have any spectator ions? No spectator ions. So what's my net ionic? The same as my complete ionic. Right? When I look at over here, do I have sodium exactly as sodium on the right side? No. Over here I have sodium plus. Do I have water on the right side? No, I don't have water on the right side because it's broken up into OH minus and H2. So I can't eliminate anything. So that means my net ionic is exactly like my complete ionic. Okay, I'm starting to get this. All right, here's the last one. You guys give it a shot. Ooh, this one looks tough. Combustion of methane. Methane we know is CH4, and it is a gas, plus O2, which is a gas, yields CO2, which is a gas, plus HOH, which it can be a gas or a liquid. And when I balance these, I need 2 of these, and which would mean what? I need 2 of these. Is that correct? Cool, I think it is. Now you can see right away, gas, 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 gas. Does anything break up? No. So that is my molecular, it is my complete ionic, and it is my net ionic. It's the same thing for all of them because nothing is aqueous. Trick question, kind of. Yeah, I guess it was. All right, folks, that would be it for today. So enjoy, and I'll see you next time.